So today we'll be seeing electromagnetic radiations. What are these electromagnetic radiations? Light and other forms of radiant energy that propagate without any medium in the space in the form of waves. Are known as electromagnetic radiations. So these electromagnetic radiations, they can be formed by a charged particle moving in magnetic field and it can be formed by a magnet in an electric field. For example, we can take X-rays, gamma rays, cosmic rays, as well as ordinary light rays, etc. There are many examples for this. Okay. So first we'll be studying this is a definition. Now we'll be studying the characteristics of electromagnetic radiations. So the first one is, all the electromagnetic radiations travel with velocity of light, which is equal to 3 into 10 per 8 meters per second or 3 into 10 per 10 centimeters per second. The second point is, these whatever the electromagnetic radiation, they include electric field as well as magnetic field, which are perpendicular to each other. Okay, and these both electric and magnetic field, they are again perpendicular to the direction the direction in which the waves are traveling. Okay, so let us show it in this form. These are the waves traveling. This is crest, this is a trough. Okay, so this is a second main characteristic of electromagnetic radiation, that the electric field and magnetic field, they are perpendicular, and both these electric field and magnetic field are perpendicular to the direction in which the wave is traveling. Now we'll be learning the third main characteristic, which is wavelength. Okay, what is wavelength? The distance between two nearest crests or two nearest troughs is called as wavelength, and it is denoted by lambda. It is expressed in terms of angstrom, centimeter, micron, nanometer. Okay, we'll see the values. 1 angstrom is equal to 10 per minus 8 centimeters, which is equal to 10 per minus 10 meters. 1 micron is equal to 10 per minus 4 centimeters, which is equal to 10 per minus 6 meters. 1 nanometer is equal to 10 per minus 7 centimeters, which is equal to 10 per minus 9 meters. 1 centimeter is equal to 10 per 8 angstroms, which is equal to 10 per 4 microns, which is equal to 10 per 7 nanometers. So this is about wavelength. Now the fourth characteristic is frequency. Okay, this frequency, it is defined as the number of waves that pass through a point in 1 second is called as frequency. It is denoted as nu. It is expressed in terms of cycles per second or waves per second or hertz, Hz. Okay. So frequency nu is equal to c by lambda. What is c here? The distance traveled by wave in 1 second, which is divided by the wavelength of a wave. So when we calculate this, we will be getting the number of waves that pass through a point in 1 second, which is the frequency. Okay, now we will be learning about the fifth characteristic of a wave, which is velocity. What is velocity? The distance traveled by a wave in 1 second is called as velocity. It is denoted by c. Okay, there is one important point here. All electromagnetic radiation travel with same velocity, which is equal to 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. So we know that nu is equal to c by lambda. What is nu here? Frequency. Then what about velocity? C is equal to nu lambda or lambda nu. Okay. So this is about velocity. The sixth characteristic is wave number. Wave number is the reciprocal of wavelength. That is, number of wavelengths per centimeter is called as wave number, and it is denoted as nu bar. Nu bar. Okay. So nu bar is equal to 1 by lambda. Now the seventh characteristic is amplitude. Amplitude is the height of crest or depth of trough is called as amplitude. Okay, the height of crest or the depth of trough is called as amplitude, and it is denoted by capital A. So this amplitude, it determines the intensity of radiation. Okay. Now the eighth characteristic of a wave is time period. The time taken by a wave for one complete cycle or vibration is called as time period. It is denoted by capital T. Okay, so T is equal to 1 by nu, and its unit is second per cycle. Okay, so this is time period. Now we'll be seeing what is electromagnetic spectrum. So I'll write the definition here because it is very important. The arrangement of various types of electromagnetic radiations in the order of increasing or decreasing wavelengths or frequencies is called as electromagnetic spectrum. The arrangement of various types of electromagnetic radiations in the order of increasing or decreasing wavelengths or frequencies is called as electromagnetic spectrum. So we have radio waves, microwaves, IR, visible, UV, X-rays, gamma rays and cosmic rays. So down this, the wavelength decreases and frequency increases. Why lambda decreases and frequency increases, nu increases? Because nu is inversely proportional to lambda wavelength. So this is what electromagnetic spectrum is.